Hello students, welcome back to my channel. So this is the after so many topics like introduction meteorology, soil and tillage, then soil conservation, dryland agriculture. Today we are discussing mineral nutrition, manure and fertilizer. So stay tuned till the end, and if you get any doubt, then you can just ask me. Okay. So first of all, what are the mineral nutrition? What is mineral nutrition and what is manure and what is fertilizer? Mineral nutrition, these nutrients are essential generally for plants. Okay, so there are 17 essential nutrients. So on the basis of what they are essential? So there is essentiality principles that is defined by Annon and Stout during 1939, and Annon later on again redefined that essentiality concept in 1952. So what is that essentiality principle? There are three principles. One is the deficiency of that element, failure of vegetative and reproductive stage in plants occurs. Then on deficiency can be corrected only by that specific nutrient. No other element can substitute that element deficiency. Then it has direct effect on metabolism of the plant. So these are if any mineral element that follows these essentiality principles, then that is called as essential element. Okay, so there are 17 essential elements. Among them, 3 are basic, like carbon, hydrogen, oxygen. Then there are 14 mineral essential element. Okay, so they are divided into primary macronutrient. Those are N, P and K, nitrogen, phosphorus, potassium. Secondary macronutrient, calcium, magnesium, sulfur, and micronutrients are there: zinc, iron, boron, molybdenum, manganese, copper, chlorine and nickel. Okay, the latest added mineral nutrient is nickel. Okay, so there are several scientists who have proposed different mineral nutrition or nutrition of plants in different way. So let's study a few of them. So Justus von Liebig, he is known as the father of agricultural chemistry, and he proposed the law of minimum and law of restitution. Pietro di Crescenzi, the father of modern agronomy, he has written a book, Opus Ruralium Commodorum. Francis Bacon proposed principal nourishment to plant is water. Von Helmont proposed water was the sole nutrient of plant. Robert Boyle, he proposed plant contains salt, spirit and earth. Glauber, he proposed saltpeter, that is KNO3, is the principle of vegetation. Woodward, scientist, he proposed earth is the principle of vegetation. Jethro Tull, he proposed fine earth responsible for plant growth, and his written book is Horsewing Husbandry. Arthur Young, his book is Annals of Agriculture, and he did experiment on barley. Ingenhouse, he proposed purification of air in light. Theodore de Saussure in 1804 proposed carbon content of plant derived from air. Sir Humphrey Davy in 1831 proposed element of agricultural chemistry. The book written Element of Agricultural Chemistry. J.B. Wossingwald, he is known as father of field plot experimentation. Lewis and Gilbert in 1843 established Rothamsted Experimental Station. Annan and Stout in 1939 criteria of essentiality, I have already told you. Nicholas, functional or metabolic nutrient. Mengele and Crickby 1978 again divided that essential nutrient into with respect to biochemical behavior and physiological function. So these are some of the scientists, they propose differently about mineral nutrients of plant. Then beneficial elements. So there are certain beneficial elements like sodium, silicon, cobalt, vanadium. They actually are not essential element, but they have certain role in different plants in their metabolism or any particular role. So they are known as beneficial element. Organic form to inorganic form, that is known as mineralization, and from inorganic form to organic form, that is known as immobilization. Nutrient supply to plant root. How plant uptake nutrient? Through root by either mass flow or diffusion or root interception. There are three mode of uptake of plant nutrient from soil by root. That is mass flow, it is generally passive energy, passive uptake. So here active energy is not utilized, that is through the transpiration pool. Then diffusion, mostly phosphorus and potassic minerals, they are entering into root by diffusion. Then root interception, actually root has its spread like 1/10 of the soil volume is occupied by root, and mainly calcium is uptaken by root by through root interception. Okay, the nutrient absorption by plants, mainly they are active active uptake and passive uptake. Active uptake where the metabolic energy is used, then passive uptake like through transpiration pool, there is no metabolic energy is used. Then soil fertility versus soil productivity. What is soil fertility and what is soil productivity? Soil fertility is the it is the property of soil, inherent property of soil to supply plant nutrient at an adequate quantity in a suitable proportion. Okay, adequate quantity and suitable proportion. Okay, so soil fertility is the function of nutrient status of the soil, but soil productivity is the function of soil fertility, management and climate. Okay, so assessment of soil fertility status, there are several assessment tests, like biological test. In biological test we have field trial, we have laboratory or greenhouse test, where like mixture leaf pot culture, where oat and nutrient omission plots are taken. Then new word seedling method, there are larger number of plants in small amount of soil taken. Okay, these are laboratory or greenhouse test. Then microbiological method, where such as Saken and Stewart technique for P and K status, they used azotobacter as carrier. Then Azospirillum niger, Aspergillus niger method, where incubation was done. Then soil plaque method for phosphorus and potassium, where azotobacter incubation was done. Then these were biological tests. Then visual symptom, this is the cheapest method, and we can easily identify mobile and immobile nutrients in this method. The indicator plants are also used in for this method. Then plant analysis is also there. In plant analysis we have tissue test, which is rapid from plant sap. We can use the tissue test, generally done at full bloom or early fruiting stage. Then total analysis by AAS, atomic absorption spectrophotometer, or ICP, inductively coupled plasma. Then the nutrient range, like deficiency, marginal, adequate, excess and toxic. These are the nutrient range. What is deficiency? When plants do not get enough nutrient to carry out these biochemical activities. Then marginal, right? Then adequate, which is luxury consumption. Excess, then toxic. Okay, critical nutrient concentration approach. This is the critical nutrient concentration approach. Then DRIS approach is also there, diagnosis recommendation integrated system, that was proposed by Bufill to identify all the nutritional factors limiting crop production for improving crop yield through an ideal fertilizer schedule. Measures how far particular nutrient in the leaf or plant are from the optimum. Okay, so what is the optimum quantity and what is the deviation from optimum? This is generally identified in DRIS. What is the advantages of DRIS over CNC, critical nutrient concentration? Nutritional balance considered, elemental content of leaf tissue universally accepted, diagnosis can be made over wider range, nutrient limit, yield can be identified. Okay, then again another method of plant analysis is crop logging. This was first used in Hawaii for sugarcane crop. Then it records nutrient at 35 days interval, that is based on a critical nutrient concentration approach. Then another is isotope dilution technique, where radioisotope of phosphorus is used, that is A value technique. Also it is A value technique. A value is equal to B into 1 minus Y by Y. So where A is the available phosphorus in soil, B is the amount of P applied to soil, Y is the fraction of P taken by the plant from B. Okay, so these are some of the assessment of soil fertility, like biological test, visual symptom, plant analysis. In plant analysis we have isotope dilution technique, crop logging, then DRIS, CNC, tissue test, total analysis test. Okay, so what is the general like concentration of different nutrients inside plant tissue? If we say carbon, that is 45%, oxygen 45%. This is assumption, or this is near to the content will nearly vary to this range only. carbon 45%, oxygen 45%, hydrogen 6%, nitrogen 1.4%. It depends whether it is cereal or pulses. In case of legume or pulses, that is high, but in cereal that is low. So nitrogen 1.4%, phosphorus 0.2%, potassium 1%, calcium 0.5%, magnesium 0.2%, sulfur 0.1%, iron 112 ppm, manganese 55 ppm, zinc 20 ppm, copper 6 ppm, boron 22 ppm, molybdenum 0.1 ppm, chloride 106 ppm. So these are some of the average concentration of plant body tissue. So soil testing. Why we test soil? To know the soil fertility status. So first we have to take the sampling in random sampling we have to do, zigzag sampling or random sampling to avoid the bias. Then prepare of that soil. Okay, we have to dry that soil, set dry. Then we have to sieve, ground that soil. We have to sieve that soil, and particular what is the sieving size also there. Then we have to take that soil for analysis. That is extraction and estimation. For phosphorus analysis, we have Bray reagent, Olsen reagent, and Melick reagent. What is Bray reagent? 0.03 molar ammonium fluoride plus 0.025 molar HCl. That is used for acidic soil extraction, phosphorus extraction. Then Olsen method, where 0.5 molar ammonium bicarbonate is used. That is used in generally neutral to saline soil, right? Then Melick extractant, 0.05 molar HCl and 0.0125 molar H2SO4. For potassium, we have 0.05 molar HCl in 0.015 molar H2SO4, double acid we can use. Then 1 molar ammonium acetate at pH 7, which is widely used. That extractant also used. For micronutrient, we have extractant like DTPA, diethylene triamine pentose acetic acid. For boron, we have hot water, right? So these are few soil testing extractants. Then calibration and interpretation is also there after extraction and all. Then relative yield. What is relative yield? Yield of control plot divided by maximum yield of treated plot into 100. Which is if the relative yield is less than 50% of if the yield is less than 50% of relative yield, that is very low. If it is 50 to 75% of relative yield, then low. If it is 75 to 100%, then medium. If it is more than 100, then high. Next we have extraction. Okay, we got that. Then extraction, estimation, calibration, interpretation, and recommendation we can do. So what is the range? Actually, organic carbon, that the medium range is 0.5 to 0.75. If it goes down below 0.5 percentage, then it is called deficient in organic carbon. If it is beyond 0.75, then it is higher organic carbon is there. Then for available nitrogen, 280 to 560 kg per hectare, it is the medium range. Then available phosphorus, it is 10 to 25 kg per hectare. Then available potassium, it is 120 to 280 kg per hectare. So how we recommend, how fertilizer is recommended. So there are several approaches. Index system that was proposed by Cope in 1973. Then soil test crop response approach, STCR. Then soil test correlation approach is also there, which is based on soil fertility map. Nutrient index value. How we can calculate nutrient index value? That is the NL plus 2NM plus 2NH 3NH by NL plus NM plus NH. Okay. So if nutrient index value is more than 2.33, then the soil is highly fertile. If the nutrient index value is 1.34 to 1.5 or 2.3, then that is medium. The fertility range is medium. If the nutrient index value is less than 1.5 or 1.3, then the fertility value is low. Soil fertility is low. So earliest long-term fertilizer experiment called permanent manual experiment started at Rothamsted Experimental Station. That is situated in Harpenden, England. And it was established in 1943, and it was established by Lewis and Gilbert. In India, the earliest permanent manual experimentation that was initiated in Kanpur in 1885, then Pusa in 1908, and Coimbatore in 1909. So only exist among them is Coimbatore. Okay. Then ICAR sponsored coordinated project on long-term fertilizer experiment started in 1970-71 to critically assess the effect of modern intensive agricultural system on soil productivity and crop yield. Then what is manure? Manure are low nutrient content, longer residual acting fertilizers. Manure are low nutrient content, longer residual acting fertilizer. Okay, what are the sources of manures? There are several sources like cattle shed waste, human habitat waste, poultry litter, slaughterhouse waste, fish waste, agro industry byproduct, crop waste, weeds, tank silt, then like manure of crop, etc. Then what are the types of manure? One is bulky organic manure, another is concentrated organic manure. In bulky organic manure, we have FYM, compost, green manure, sewage, sludge. Then there are different types of composting also, like Coimbatore method, Indo method, Bangalore method. Coimbatore method is generally anaerobic decomposition followed by aerobic fermentation occurs. In Indore method, that is bulky method. In Bangalore method, that is reverse of Coimbatore method, that is aerobic method. Then okay, so concentrated organic matter. What are the concentrated organic matter? That is oil cake, bone meal, guano. Guanos are rich in nitrogen and phosphorus. Bone meal are slow acting, ideal for acidic soil and long duration crops. And oil cake, the CN ratio is 3 to 5, quickly nitrifying. Exception, mohua cake. Then vermicompost is also there. Then what are the species mainly used in vermicomposting? Eisenia foetida and Eutyllus eugene. Rate of application in field crops, the vermicompost rate is 1.5 to 3 ton per hectare as basal, 1.2 to 1.5 ton per hectare at 4 leaf stage, and 1.2 to 1.5 ton hectare at flowering. And fruit trees 1 to 10 kg per tree it is recommended. Then vegetable 10 ton per hectare it is recommended. Okay, then fertilizer. Fertilizer are generally chemically synthesized. Okay, so nitrogenous fertilizer. Generally the total soil nitrogen is 1.2%. Available nitrogen is 1.2% of total soil nitrogen. So you can imagine the available nitrogen in soil is 1.1 to 2% of total soil nitrogen. So what are the nitrate fertilizers? Actually nitrogen fertilizers are again divided into nitrate fertilizer, ammoniacal fertilizer, amide fertilizer. Okay, so what are the nitrate fertilizer? Like sodium nitrate, calcium nitrate, potassium nitrate. These are the nitrate fertilizer. Ammoniacal fertilizer, these are ammonium sulfate, ammonium hydrogen phosphate, ammonium phosphate, ammonium chloride, ammonia. Okay, anhydrous ammonia. Then nitrate and plus ammonium, like ammonium nitrate, calcium ammonium nitrate, ammonium sulfate nitrate. Okay, so ammonium sulfate is very low hygroscopicity, having very low hygroscopicity, chemical stability is more, and agronomic suitability is more. The acid equivalent is 110 and it contains 21% nitrogen, 24% sulfur. Manufactured by synthetic process or gypsum process. And ammonium chloride, it is best used in rice, should not use in chloride sensitive crops like coconut, tobacco, etc. Then it is synthesized by dual salt process, where modification, which is a modification of solvay ammonia soda process. Okay, ammonium nitrate, it is explosive fertilizer. Okay, then amide fertilizer, urea and calcium cyanamide. So urea, we are generally mostly used urea. Okay, then ammonia, anhydrous ammonia, it contains highest amount of nitrogen, 82%, and it is generally deep application is recommended, 10 centimeter deep application, and can applied with irrigation water also. So urea, that is diamide of carbonic acid. So in hydrolysis of urea, ammonium carbonate of first product is ammonium carbonate, that is microbial oxidation. Urea should be placed in reduced zone to prevent denitrification losses. Okay, so how biurate form from urea? Whenever urea is synthesized in 140 degree or 170 degree Celsius, then biurate form. What is the formula of biurate? That is two urea mixing of two urea molecule and ammonia releases ammonia molecule, that is NH2CONS. Okay, urea, the formula of urea is NH2CONS2, and the formula of biurate is NH2CONS. So what is the recommended what is the maximum limit of biurate in urea? That is according to fertilizer control order. If we are going for basal application or we are broadcast application, then that is maximum limit is 1.5%, and if we are going for foliar application, the maximum limit is 0.25%. Then There are slow release nitrogen fertilizer and nitrification inhibitor. Why this is required? Because the nitrogen fertilizer, their efficiency is very low because there are several losses like volatilization, denitrification, and leaching, then all these kind of losses are there in nitrogen fertilizer. So we have slow release nitrogen fertilizer like urea form, chlorine diurea, CDU, IBDU, isoprene diurea, UZ, oxamide, GUS, SCU, NCU, neem coated urea. These are slow release nitrogen fertilizer. Then nitrification inhibitor like NSORF, that is 2-chloro-6 trichloromethylpyridine, AM, that is 2-amino-4-chloro-6-methylpyrimidine, then thiourea, methionine, cyanoguanidine, sodium and potassium azide, diethane, dithiocarbamate, etc. These are nitrification inhibitor. Then urease inhibitor. These are NBPT, PPDA, cyclohydroxamine acid. That metal ion including silver, mercury, copper, these inhibit urease activity. Okay. So nitrogen use efficiency varies from 30 to 50%. What is apparent nitrogen recovery efficiency? That is uptake of nitrogen from nitrogen applied plot minus uptake of nitrogen from control plot divided by nitrogen fertilizer applied. Then agronomic efficiency, yield from nitrogen applied plot minus yield from control plot divided by nitrogen fertilizer applied. What is physiological efficiency? That is yield from nitrogen applied plot minus yield from control plot divided by uptake from nitrogen applied plot minus uptake from control plot. Then phosphatic fertilizer. This is all about nitrogen fertilizer. Then phosphatic fertilizer. Okay, so soil phosphorus generally in inorganic form it is bound with calcium, magnesium, iron and aluminum, etc. It is generally in acidic soil it is bound with iron and aluminum, and in saline soil it is bound with calcium and magnesium. Then in organic form there are inositol phosphates, which is about 20% of organic phosphorus, that is highest. Then nucleic acid, phospholipid. Okay, these are the form of organic phosphorus. Then what is mineralization? When mineralization occurs, when the residue concentration is more than 0.2% and the CP ratio is less than 200:1%, then mineralization of phosphorus, organic phosphorus occurs. Phosphorus availability maximum at pH. Actually pH determine the phosphorus availability in soil. So what is the range of pH where soil phosphorus is maximum, availability is maximum? That is 6 to 7. So availability of inorganic soil phosphorus, that depends on pH, precipitation by aluminum, iron, magnesium, acid soil, reaction with hydrous oxide, fixation by silicate clays like sesquioxide and phosphate ratio is there. Inorganic phosphorus availability in soil with high pH, organic matter and microbial activity also influence soil phosphorus availability. So there are intensity and quantity factor of phosphorus also there. Intensity, that is available of in the soil solution phosphorus, then quantity factor, that is fixed by different minerals. Okay, so intensity factor or soil solution phosphorus is about 0.2 ppm. Then yield increases. Then potential buffer capacity is the change in quantity factor divided by change in intensity. So if we convert the phosphorus form to P2O5, phosphate pentoxide form, then we have to multiply the percentage of phosphorus into 2 like with 2.29. the factor is 2.29. If we want to convert the oxide form of phosphorus to percentage of P, then we have to multiply 0.43 with P2O5. Okay, so this is you have to remember. Phosphorus content in fertilizer generally expressed in P2O5 equivalent form. Then phosphatic fertilizer, there are 3 types of phosphatic fertilizer. One is water soluble phosphatic fertilizer, another is citrate soluble phosphatic fertilizer, another is citrate insoluble phosphatic fertilizer. So all these forms are of total P. Then available P among them are soluble, water soluble and citrate soluble phosphatic fertilizer. They are available P. Okay, so let's see some of the phosphatic fertilizer. First one is SSP, single super phosphate. The formula is calcium, CaS2PO4 whole 2 dot H2O, then CaSO4 dot H2O. Okay, this is prepared in batch mix process where rock phosphate, where H2SO4 is applied to rock phosphate in 1:1 ratio. So what is the P2O5 content? 16 to 18%, and there is 12% sulfur in SSP. Then 21% calcium is in SSP. Then TSP, triple superphosphate. This is when rock phosphate is applied with phosphoric acid, TSP is formed. Then it contains 48% water-soluble phosphorus and 18% lime. Then ammonium phosphate, monoammonium phosphate, diammonium phosphate, these are ammonium phosphates. This reacting ammonium with phosphoric acid or mix of phosphoric acid plus sulfuric acid. Okay, so then nitrophosphate, nitric and sulfuric acid when reacted to rock phosphate or apatite, then nitrophosphate generates. 1/3 of water soluble and rest are citrate soluble. In nitrophosphate, 1/3 of them is water soluble and rest is citrate soluble. And nitrophosphate is best suited for acidic soil and long duration crops. Then bone meal. Bone meal also contain decent amount of P2O5, that is 25. Raw bone meal contain 25% of P2O5 and 4% nitrogen, and steamed bone meal contain 25 to 30% P2O5 and 1 to 2% nitrogen. This is bone meal is citrate soluble P2O5 and mainly used in acid soil. Then basic slag, byproduct of steel industry, high specific gravity and 8 to 12% P2O5, and generally recommended for acidic soil. Then rock phosphate. Rock phosphate is partly acidified rock phosphate is generally used. Addition of equal quantity of H2SO4. This is effective when it is in powder form and broadcasted in acidic soil, and this is recommended for long duration crops. Then potassic fertilizer. More than 95% of total soil potassium fixed in soil minerals, that is in mica or feldspar. These are highly potassium rich minerals. There are 4 forms of potassium minerals in soil, potassium in soil: water soluble potassium, exchangeable potassium, non-exchangeable potassium, lattice potassium. So among this, lattice potassium is highest, that is more than 95%, which is mineral fixed potassium. Okay, so potassium fixation high in 2:1 clay mineral, that is light. Main source of potassium fertilizer are carnallite, KCl-MgCl2 6H2O, kyanite, KCl-MgSO4.3H2O, langbenite, K2SO4.2 and sylvite, KCl. Okay, if we want to convert percentage K to percentage K2O, we have to multiply 1.2, and if we want to convert percentage K2O to percentage K, then we have to multiply 0.83 in percentage K2O. So let's see some potassium fertilizer. First one is widely used MOP, muriate of potash, that is the formula is KCl, potassium chloride. It contains 60% K2O. Dissolving sylvite or sylvinite in hot water and adding NaCl to it. So this is the procedure. Then K2SO4, 2 ways. Its preparation is in 2 ways, like langbenite and Mannheim process, and it contains 52% K2O and suitable for potato and tobacco, which are chloride sensitive crops. Then calcium, anorthite CaL2Si2O6, calcite CaCO3, gypsum CaSO4.2H2O. These are some of the calcium containing mineral. If we want to add calcium to soil, then we can add these minerals to soil. Then magnesium, it is mainly seen in biotite, olivine, serpentine, dolomite. Magnesium deficiency, when magnesium deficiency occurs, when the calcium magnesium ratio is greater than 7:1, then magnesium deficiency we can find in soil. Recommended potassium magnesium ratio for field crop, that is less than 5:1, for vegetable less than 3:1, for fruit crop less than 2:1. What is the optimum CNS ratio? 130:10:1.3. Optimum NS ratio for legume, that is 15 to 16:1, and optimum NS ratio for cereals, that is 11 to 12:1. Factors affecting zinc availability, that are pH, phosphorus, organic matter, adsorption by clay. Sources of zinc, mostly use zinc sulfate heptahydrate, and another is zinc sulfate monohydrate. Zinc sulfate monohydrate contains 33% zinc, and zinc sulfate heptahydrate contains 21% zinc. Then zinc ADTA, it contains 12 to 14% zinc. Zincated urea, it contains 2% zinc. Zinc oxide, it contains 55 to 20% zinc. Then iron containing minerals: olivine, pyrite, siderite, hematite, magnetite, limonite. What are the factors of iron availability? That is pH, organic matter, and submergence. For manganese, these factors also valid. Then copper deficiency, it causes reclamation disease. Boron is the only non-metal among the micronutrient. Among all the micronutrient, boron is only the non-metal micronutrient. Okay, okay, boron containing minerals: borax 11% boron, borate 14% boron, and boric acid 17% boron. Molybdenum, the extractant used for molybdenum extraction, that is ammonium oxalate in pH 3.3. Then the mineral contain ammonium molybdate, mainly used for molybdenum supply, that contain 54% molybdenum. There are two factors which affect molybdenum availability, that is pH and sesqui oxide. Then fertilizer and their percentage. Okay, ammonium percentage of sulfur, some fertilizers, sulfur containing fertilizers, and percentage of sulfur. Ammonium sulfate 24% sulfur, ammonium phosphate 4.5% sulfur, ammonium phosphate sulfate 15.4% sulfur, basic slag 12.4% sulfur, SSP 22.4% sulfur, potassium sulfate 17.8% sulfur, gypsum 23.5% sulfur, and iron sulfate 18.8% sulfur. Okay, next, what are the chelates we use generally to apply micronutrient or extraction of micronutrient? These are EDTA, DTPA, EDD, HA. Okay, so what are the antagonistic effect? There are certain antagonistic effect found in soil between different minerals. So what are they? If the increase of copper and sulfur occur, then there is a decrease in molybdenum. If increase in zinc, copper, molybdenum, there is decrease in iron. If increase in phosphorus, then increase in molybdenum and decrease in iron, zinc, and copper. If increase in nitrogen, then decrease in copper and zinc. Then if increase in lime, then decrease in boron. If increase in iron, copper, and zinc, then decrease in manganese. Okay, so these are the antagonistic effect. Then mixed fertilizer. Why we will mix the fertilizer? And there are two types of mixed fertilizer actually: open formula and closed formula. Open formula is mentioned in the on the fertilizer container, and closed formula, it is not disclosed by the company. So about then fertilizer application, there are different principles of fertilizer application, like what kind of fertilizer it is, then quantity of fertilizer, whether threshold dose or minimum recommendation dose required, or optimum dose required, or maximizing dose is required. Then frequency of application. If it is sandy soil, then we can go for split application. If it is like clay soil, or if we are applying nitrogen, if we are applying phosphorus and potassium, then we should go for basal application only. Then time of application, placement of fertilizer, method of application. So in solid fertilizers are generally applied as broadcasting, top dressing placement, plow soil placement, deep placement, localized placement, contact or drill placement, bound or hill placement, pellet application, side dressing, etc. Liquid fertilizers are generally used as starter solution, foliar application, soil application, fertigation. Then balanced fertilizer application, that is fertilizer dose is equal to NR, that is nutrient requirement, divided by FE, that is fertilizer efficiency, divided by 100 into target, minus soil efficiency divided by fertilizer efficiency into soil test value. So then INM, integrated nutrient management. What is INM? We are using chemical fertilizer, biofertilizers, and inorganic fertilizer in INM to like sustain the soil productivity and to minimize the effect of only chemical fertilizer application. Okay, so fertilizer and environment, fertilizer and soil. If we go on increasing the fertilizer rate, then it reduces partial factor productivity, it reduces the soil fertility, it reduces the soil health. Then fertilizer and water, there are eutrophication effect of fertilizer. If the fertilizer is carried to a water body, then there is eutrophication effect, biological oxygen demand increases. Then blue baby syndrome, if nitrate content of like water is more than 11 ppm, then blue baby syndrome we can it can happen. In fertilizer and air, there are certainly acid rain, greenhouse gas emission is also due to fertilizer, due to more application of fertilizer. So there are certain objectives, those questions are I have written, and these are generally asked in different competitive examinations. So what is the formula of saltpeter? That is potassium nitrate. Nutrient related to water oxidizing enzyme complex, that is manganese. Iron deficiency is more prominent in which kind of soil? That is calcareous soil. When submergence occurs, then there is availability of increases in availability of phosphorus, iron, and manganese, and reduced availability of copper and zinc occurs. Preferred nitrogen fertilizer in tea plantation, that is ammonium sulfate, because tea is also chloride susceptible. Okay, chloride sensitive. End product of organic matter in decomposition. That what is the end product? That is humus. Nitrogen level in sugarcane leaf tissue to be deficient. when we call the sugarcane leaf is deficient in nitrogen, when the tissue leaf tissue nitrogen content is less than 10 ppm. Phosphorus availability maximum at pH 6 to 7. A value technique was developed by Fred and Dean, and it is used to estimate phosphorus and sulfur. Competition for nutrient begins early for immobile nutrients. For immobile nutrients, competition begins early than mobile nutrients. Ferrous sulfate heptahydrates contain iron. What percentage? 20%. Biosuper, what is the constituent of biosuper? Rock phosphate plus sulfur oxidizing bacteria. Optimum temperature for nitrification is 30 to 35 degrees Celsius. Optimum pH 8.5 and percentage nitrogen. Okay. Sulfur content in phosphogypsum is 16%. Iron deficiency is generally seen in 7.4 to 8.5 or calcareous soil. Okay, soil having more P2O5 but less K2O is alluvial soil. Alluvial soil has more P2O5 but less K2O. Barton's reagent, that is ammonium molybdate plus ammonium metavanadate, that is used in phosphorus estimation, right? Black heart in groundnut and brown spot in potato due to deficiency of calcium. Rhizobum species for black gram belongs to cowpea group. White board of maize is due to deficiency of zinc. Isomorphous substitution is independent of pH, soil pH. Okay, so if soil pH increases, there is increase in CEC. Remember this relation. If there is increase in pH, there is increase in CEC, cation exchange capacity. Total surface negative charge to attract cation, that is CEC. It is formula. The unit is 1 milli equivalent per 100 gram or 1 centimole per kg. The extractant for estimating CEC is 1 neutral normal ammonium acetate. Element that is absorbed almost equal through mass flow, diffusion and root interception, that is zinc. Element that can be completely supplied with root interception, that is calcium. Liming in potato soil, that increases potato scab but decreases club root of potato. Percentage nitrogen in aqua ammonia, that is 20 to 25%. Percentage nitrogen in anhydrous ammonia, that is 83%. Okay. Plant available phosphorus, that is water soluble phosphorus plus citrate soluble phosphorus. Readily available potassium, that is soil solution potassium and exchangeable potassium. We read there are 4 kinds of potassium. Okay. From that, readily available potassium is soil solution potassium and exchangeable potassium. CS ratio, optimum CS ratio is 200 to 400 is to 1. Bronzing occurs due to when iron concentration in leaf is greater than 300 ppm. Rosetting in citrus due to zinc deficiency, right? So this is all about mineral nutrition, soil fertility, manure and soil fertility. So if you have any doubt, any query, then you can ask me. Okay, so stay tuned for rest of the chapters. You will get notified very soon. Bye bye.